Hey everyone. Now I decided to do a bit of network analysis on the car, which is a 2017 Tesla Model S. So I'll show you what I saw on Wireshark here. Alright, here's a packet capture I took on the router and had running for a while. So here's the sort of stuff that's in it. You see lots of stuff here. I'm going to go through it and pick it apart. So first of all, DHCP. Okay, now in this column I've got the time delta between the previous displayed frame. So you can see it's roughly every 2 minutes it's doing a full DHCP setup. So you can see it's doing the whole discover, offer, request and ACK. And you can also see that they've all got, well, the set of 4 all have different transaction IDs. So it's starting a whole new process, which isn't normally what would happen. It's not a renew because that would just have a request and ACK. And also in the ACK, you can see down here, the least time is 2 hours. So it would do it after an hour, but this is happening every roughly 2 minutes. So that was the first thing that was strange. I did find one of them though that stayed on. So this is a normal looking one. You've got the discover, offer, request, ACK, and you can see it's the same transaction ID an hour later, 3600 seconds, which is half of the 2 hour lease time. And it just does, as I said, the request and ACK. So that's normal, but the rest weren't. It's like they were stuck in some kind of loop. Now I found some good old port 80 HTTP here. And I'm just showing the associated DNS request for it. So you can see it went to teslamotors.com. And all it was doing was trying to get to the root directory and failing. So if I follow the HTTP stream, this is what you can see. So of course, using curl, it tried to get the root and there was no roots there. So got the 400 error. And of course, there were many of them. And if I put DHCP on here as well, you'll see that's the sort of thing it was doing. DHCP, couple of goes at that HTTP, drops off. DHCP, couple of goes at HTTP, drops off. All that mess, didn't even have a go. Just all that horrible DHCP. You can see the green bits of HTTP in the middle of it. So there was a lot of that mess going on. Okay, now onto DNS, and I tell it to use 10.254 as the DNS server, which is my Pi-hole. And for the most part it uses it, but there were some instances where it used 8888, which is not what it should have done. Either way, I capture that at the router and redirect it to 10.254 anyway, but you can see that sometimes it bypasses what I told it and tried to do its own thing. Now you can see most of this is Tesla this, Tesla that, but I'll show you something else. It used a different DNS server, this .104.105 here, to go to these types of things like bloody Netflix, YouTube, NY Times, Target, just stuff that really has nothing to do with being a car. And what I found was this destination seems to be a Telstra DNS server. So if I look this up, it falls within the Telstra subnet. And the only thing that's Telstra to do with this whole household or that car is the SIM card inside it. So its mobile network would be Telstra. So it's like there's a different DNS setup that came from the mobile network, even though this is on the Wi-Fi network. So it's a bit all over the place the way it's constructed there, it would appear. Now I've got this Hermes thing, which is just this Hermes stream, blah, 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 Tesla services, and the 2 addresses that it resolved to. And this is what most of the traffic was, just this HTTPS stuff on 443. That would be how it connects back to Tesla to pass all the info that it's collecting up. Now in the past when I did this a few years back, it had OpenVPN there on UDP port 1194, but they seem to have got rid of that now and using TCP 443. Now here I'm just looking for the start of those connections, just the SYN flags, as it tries to connect to them. And you can see there's heaps of them because you saw it just does lots of these small sessions. But one thing I noticed, if I look at this port here, I'll see a session, okay, SYN, SYNAC, ACK, a bunch of data, and that's it. But down here, I see the port numbers reused, and I see a new session being started. So there's your SYN, SYNAC, and ACK. But I don't see the old one getting closed or reset. So if you have a look at this, there's a lot of time that's gone between the old one and this one. But I still didn't see any fin. It's like it just silently dropped after, a couple of hours. So if I look at the time when that was, it was 1 in the morning, so I wasn't driving or anything, I would have been asleep. And the one before it was 8:45 at night, so the car would have just been sitting in the garage. I don't see why it couldn't cleanly finish the old session before trying to do a new one with the same source port, that 59970. Now I'm looking at SSDP, but I'll just show you on a different capture because I've got something else on this one. So here's SSDP, still a capture of the car on the router, just a different time. Now it's requesting server by name, which is just the name of the server on my network here. Okay, just a normal DNS request, purely for server. Now it must have learnt that somehow, And the way it learnt it would have been, I've got this actually leaking out. I didn't mean to have this here, but from the IPv6 link local, I've got SSDP announcing, I'll show you the whole thing. I've got it announcing the SOAPy server, and the name is server. So it would have heard that. So even though there's no IPv6 on the car that is sending out the network, it obviously still listens on IPv6 because it heard that and learnt it. So there it is there, telling it via SSDP that there's server there. And the next thing that happens is the car starts querying for server. So it's picking up info around your house and trying to get to it, which there's no need for that. I'll get rid of this too, because that wasn't supposed to be sending out on that VLAN, but I'll sort that out. So next is NTP, and you can see it's doing it every couple of minutes like it was doing DHCP. So when it brings the network up after DHCP, it does some NTP. The thing I found curious about this is it never does a lookup to get these addresses. So here I'm just looking for any DNS with those addresses in them, and as you can see, there are none. One other thing I found peculiar was it was looking up the name PPP0, which is what you'd usually call a point-to-point protocol link that you set up, like a network interface name. So I don't know why the hell it's looking up that. It makes no sense at all. Anyway, if you take away the port 443 stuff, port 80, DNS, NTP, ARP, DHCP and SSDP, there's nothing left. So that's all it's going through. Okay, so that capture was done on the router, looking at all the layer 3 traffic as it was going through. But what I'll do now is show the Wi-Fi capture so we can see what sort of RF stuff it's doing with 802.11. Okay, so here's the Wi-Fi capture. And I've just put a column in here showing the data rate. The one that says parrot is the car. Okay, so whenever you see parrot, that's the car. So it's doing a broadcast probe request, basically to see whatever's there. So all me and the neighbours and Swanee, whatever else is, replies. And this is, except for my one here, that's 11 meg. All the rest are 1 meg a second, which you know my opinion on that. Anyway, it probes around and finally it says, okay, I want to authenticate to this one here. Let's just get this organised here. It does an authentication, which is basically a handshake, and that's going to be authentication success. Then it does the association, gets the association response. Straight after that, of course, because it's a pre-shared key, you got the four-way handshake. Once that's done, all the other stuff comes through like I showed you on the wired side. The reason I can decrypt this is because I've put the password into Wireshark here. But what you'll notice is the maximum data rate you'll see is 54 meg. That's because the car is only 802.11g. So if I go to one of the association requests, you can see that, yep, there's your supported rates. There's no HT field here for high throughput for 802.11n. It's just 802.11g. If I have a quick look on my Wi-Fi network, you can see if I sort by type, it's the easy one to find. It's the only one that's got a G network on it. Anyway, if you look over here, I've got this coloured in such a way that the reds are retries. So you can see a lot of retries here. That's the, well, I've got it marked here. My router ARPing for the car. That's because the car's disappeared. And then it comes back, does the usual probe request, response, authentication, four-way handshake, DHCP, a bit of that stuff that I showed you before, a bunch of resets, and it pisses off again. So what I've got here is just the management frames. So you can see the authentication, association, and a deauth. Basically, just after a minute later. Probe around, auth, association, a minute and a half later, deauth. Blah, 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 deauth. So it just does not want to stay on the network for much longer than a minute and a half, 2 minutes. I don't know why, but that's what it's doing. If I just quickly filter on ePOL, it'll show you the four-way handshakes, which is basically what happens every time it associates. So you can see it's got that 2 minute mark here. So when you saw before on the wired side doing DHCP, that basically happens after the ePOL and the association. So, or DHCP, you'll see it here. So there you go. Does that and does DHCP, bit of stuff. 2 minutes later, does it again. So if I just look at data frames, you can see what's there. Again, it's like the stuff I had before. Same sort of thing. Now here's where I found something really interesting when looking at probe requests. You can see that it's requesting my network, PSK, that's me. But you can also see it's doing a probe request for this mad long SSID here. I'll just show you that. So there it is there. Now that SSID is 32 bytes long, which is the maximum you can have. But these hex characters don't map to anything reasonable in ASCII. So you can see over the side here, that's not a bunch of letters or anything for the SSID. It's just this business. So you wouldn't really be able to set that up as an SSID on your APs anyway. So why is it requesting that? Well, I looked it up, that big long bunch of hex there for the SSID, and I found something. It came up here from this guy saying random bytes that. Now that's exactly the same as what I've got there, okay? Exactly. And you think, well, okay, what's he talking about? He's talking about TPMs. Now, TPM is a trusted platform module which is involved in encryption and stuff, but it also has a random number generator. So you can actually run that, TPM2 get random, and just showing hex of 32 of them, and there they are. So you can just keep doing random ones. So I find it extremely bizarre, peculiar, and interesting that the random bytes that he's got here in this GitHub thing exactly matches the probe request coming from the car, given that that's not something you could set up as an SSID on an AP because it's not normal ASCII over here. So I'll look this guy up, and it comes up with this company Roxys. So I'll look them up, and it's got autonomous charging, and there's a power cable that looks a lot like a Tesla one, and in a second you'll see a Tesla rolling around in the background. You don't find that suspicious? So I find it very interesting that this so-called random number that came from the TPM is in his forum post that maps to him, that goes to this autonomous charging company. And the chances of this number coming up the same is pretty fucking non-existent. So I would dare say there's a connection there. Make of that what you will. So there's the Wi-Fi capture. It's 802.11g, which is sad because it's a 2017 model, and 802.11n came out in 2009. So that's a bit piss poor even for its day. Okay, so that's how the network looks. And the layer 3 stuff, as you saw, is a bit all over the place, so it's a bit messy. But the Wi-Fi in particular could have been a lot better. Now, I'm going to pick on Wi-Fi because that's kind of my specialty. And look, to be honest, there's a lot of Wi-Fi clients out there doing silly things as well, so that doesn't really surprise me. But just don't assume that because it's this massive company that they're doing things right. That could be improved a hell of a lot in my mind. Anyway, thought I'd share that with you. So till next time, take it easy.